This is a video demonstrating cataract surgery by phacoemulsification with intraocular lens implantation. A clear corneal incision is made using a disposable round crescent blade with a sharp cutting surface. A lamellar tunnel-like incision is made into the cornea. The incision is then completed with a sharp disposable teratome to make an anterior chamber entry. Side port incisions have already been made using an MVR blade. And then through the side port, air is injected into the anterior chamber. Trypan blue dye is injected to stain the anterior capsule. The dye is washed out with balanced salt solution using a cannula. Through the main central incision, an ocular viscosurgical device or viscoelastic material is injected to form the anterior chamber. A bent 26-gauge disposable needle is used as a capsulotomy needle through the side port to perform the anterior capsulotomy. The anterior capsule is punctured in the center, and then the flap created is turned around in a concentric fashion with gentle pulling and pushing movements of the bent needle tip to provide a central, continuous, curvilinear capsulorhexis or opening in the anterior capsule, which is a CCC type of capsulotomy. You can see the anterior capsular flap being nicely rolled around, and the capsulotomy is completed to give you an adequate opening in the capsule to perform the cataract surgery. Part of the viscoelastic is expressed out, and then balanced salt solution is injected underneath the edge of the anterior capsule to perform hydrodissection to enable adequate separation of the lens from the capsule and allow a free rotatory movement of the nucleus for facilitating subsequent phacoemulsification. So the nucleus is now being rotated using the cannula tip to manually move it around in the capsular bag. A little bit of resistance was noticed, so further small quantities of fluid are being injected underneath the edge of the anterior capsule to free the nucleus more completely. The phacoemulsification probe is now inserted through the main incision along with a second instrument through the left side port, which is a chopper. The phacoemulsification probe is used to make a trench in the nucleus. Notice the metal probe surrounded by a silicone sleeve which has an irrigating port which allows continuous irrigation of balanced soil solution into the anterior chamber to maintain the anterior chamber and prevent heating up of the phaco tip. So a central trench is being created in the nucleus using the phacoemulsification probe. The phaco needle is inserted into the nucleus and a horizontal movement is made to emulsify the nucleus. The nucleus is now being rotated, and along the lines of the trench, the nucleus is divided into two pieces. The nucleus is again being rotated so that one of the pieces is now lying inferiorly. The probe is now embedded into this half piece of the nucleus. Once it's embedded into the nucleus, it's lifted up, and the nucleus is then again divided into another two pieces using the left hand chopper to chop and cut the nucleus into smaller pieces. The nucleotomy or nucleus removal is thus completed by repeated holding, chopping, and aspiration of the nuclear pieces. The holding power of the phacoemulsification tip is determined by the vacuum built up in the machine. So the nuclear fragments are now being removed. These nuclear fragments are the central core of the nucleus. They are harder fragments and require phacoemulsification energy to emulsify the pieces and allow them to be aspirated out through the port. The phaco probe is